Hi, I'm Alex, and I'm going to show you a demonstration that will hopefully help you to understand fluid flow around an object a little bit better. This is prompted by a problem I got wrong on a thermodynamics homework. In this problem, we were asked to find the power required by a whale to progress at a constant velocity in seawater. We took the whale to be an ellipsoid and had to calculate the force of drag on the whale and multiply by the velocity to get the desired power. For a constant velocity, the force of drag and the force of the whale must cancel each other out. This can be modeled by a football in an airstream. The football in this demonstration will be taking the place of the whale, and the air will be acting as the seawater. Both water and air are fluids and behave similarly around objects immersed in them. Another important point is that the football is not moving forward as the whale was. However, what is important in fluid dynamics are the relative velocities of the object and medium. The water was not moving in the problem, but air is in this case, so it works out the same. Also, instead of the power involved in keeping the whale moving forward, we have the power my hand is providing to keep the ball in place, assuming we're disregarding gravity and only care about the power necessary to keep the football in the same horizontal position. Now for the demonstration. As I bring down the rod, notice how the attached thread string seems to follow the shape of the football. The air is pushing the football back, but is also traveling around the football in a predictable path. There is some fluttering in the string, but it is keeping the same shape. However, as I move the string back along the football, it starts to flutter around more. The airflow has gone from nice and smooth laminar flow to rough and unpredictable turbulent flow at the back. The total force of drag is dependent on the density of the medium, the speed, and the length of the object, but also on a coefficient of drag. When the flow goes from laminar to turbulent, there is a lower coefficient of drag, since the air isn't going so nicely around the object anymore. It is not just pushing against the ball, but going everywhere. In the case of an ellipsoid, like a football or whale, the coefficient of drag halves when the flow becomes turbulent. So, to find the power, we had to know if the flow was laminar or turbulent to get the right coefficient of drag. In our case, it was turbulent for the whale, or football. And from here, it was only a matter of multiplying the right values to get the final answer.